Those are the same, yeah. Okay, so this is what it looks like to be in vertex form right here. I'm not going to go into what a vertex is, what the axis of symmetry is, and those things. Kind of a review. The A right here is the same A that we talked about in standard form and on intercept form. The A is the stretch. Right? Also, if A is negative, it opens down. If it's positive, it opens up. Right? So the same rules before. The biggest thing that is different is the vertex. So vertex can be found from this and this. Now remember when we were doing intercept form, how we had that x minus p and the x minus q, and then we had to take the opposite of what was in here to find the actual intercept, right? It's flip the sign. The same is true with this. Because of the negative right here, it flips the sign of the vertex. So whatever is in here, we take the opposite, and that is the x part of the vertex. So you gotta flip the sign. And then the k is the y part of the vertex. You do not flip the k because of the plus right here. You keep the k by whatever it says there, keep the k.
Pardon the interruption. Could we have Aaron Barlow come to the counseling office, please? Aaron Barlow.
Yep. Disregard that. Yes. Only H flips, yes. H is the only one that flips. Now the axis of symmetry, when you look at the example right here, the axis of symmetry is x equals 2 because it goes through 2, right? 2 is the x part of the vertex. So the axis of symmetry is going to be x equals whatever the H is, those will be the same. And the vertical stretch, compression, reflection, those all have to deal with A as well. If A is greater than 0, if A is greater than 1, I'm going to call it a stretch. And what happens is it looks, you can take the parabola and you pull it tighter, it looks like it's been stretched vertically. So vertical stretch. If A is less than 1, or if it's a fraction, what is what I mean? So 1/2, 1/3, 2/5, 7/8. I'm going to call it a compression. And what's happening here is it's like the parabola has been sat on, and so it looks lighter because it's being compressed down. You can imagine it where a balloon, and if I were to sit on it right here, out here would get wider, right? Kind of how that balloon in the air would work. It's kind of the same thing. So if it's a fraction less than 1 greater than 0, it's going to be called a compression. And if A is negative, I'm going to say that it's been reflected. So opening down and reflected are kind of the same thing. I'm taking the parabola and I'm flipping it down, that's a reflection. You've probably heard that word before, right? When you did, probably in secondary 1, maybe in math 8, I'm not sure. Yes. The exponent, because it's a quadratic, the exponent is what gives it its shape. Without the exponent, it would be a line. So this word will always be it's part of the consistent. Likewise, if that were a 3, it would change the shape so it would look like this. So it just determines the shape of the graph. Okay, so let's practice really quick. Let's look at part A. You're asked to do several things. You need to find your vertex. You need to find an axis of symmetry. Let's just start with vertex. The vertex comes from this number and this number. Which of those two numbers, raise your hand if you know, which of those two numbers do you flip the sign? Is it the 3 or is it the 2? Let's go first. The 3, good. You may not give yourself a point, right? It's 2. So, this is negative 3, which means my vertex is at positive 3. Do we flip the 2? No. So right here, my vertex is 3, 2. Look at Hey, raise your hand when you got it. Caitlin? Okay. When you get 2 points, everybody else got that 2 points. So the 9 is flipped to a negative. More positive flips to negative, or if it's already negative, you make it positive. Alright, try the same thing, but do it for part E. Okay, let's go, Brady.
5 negative 2.
Good. Any questions with finding the vertex? Let's look at the axis of symmetry then. The axis of symmetry goes through the x part of the vertex, right? So for this one, it would be x equals 3. And it goes through the x part of the vertex. What about on part B? What would it be? Okay, 3 times we know. So Brooklyn? X equals 9. Good. X equals negative. You know that if I do, everybody else knows I'm going to keep saying it, or get that. Okay. And what about part E? Raise your hand if you got it.
5.
You get full credit?
X equals 5.
Good. Very good. Now let's talk about opening up and opening down. A in this case is 1, right? So A is positive. That means does the graph open up or does it open down? It opens up because it's positive. On your own, try part B. Does it open up or does it open down? Raise your hand when you got it. So Natalie. Up. Good. Natalie gets 2. You knew that you get 1. What about part E? Does it open up or does it open down? Open? Open up. Good. Okay, let's see. Take the vertex, axis of symmetry. Does it open up or down? Also state if there is a vertical stretch compression. So these two can be stretched and compressed at the same time. Can I pull it skinny and then push it fat at the same time? That doesn't make I can't pull it. It's an accordion, right? You can't. It's one or the other, right? Now, can it be stretched and reflected? That is possible. Can it be stretched and then flipped? That is possible. I just can't press and push it and then flip. Now, one of these 3 has been stretched. Which one? B. Good. What on part B? 2 points for the way from the version. What, by the way, tells me that this one's been stretched? What's the number? What's the part on the equation that tells me it's been stretched? Jamie? The A is 2. Good. And the other A's are 1. Maybe get 2 and then we have 2 and 2. Good. Now, what's your notice about C, D, and F? Why did I skip those for a second? What's different? Or how many of you see a difference between those? Emma? Yeah. Parts of the equation are not. On part C, there's nothing there with the x, right? And on part D, there's nothing here afterwards. It may be, as you're starting to learn it until you see it better, it may be worth your time to rewrite it. I'm going to call this Vertex Form. Get in the habit of making a minus, even though minus 0 and plus 0 are the same thing. Keep it as a minus. There's minus 2. I'm going to call this Vertex Form. On your assignment today, several times it'll ask you to rewrite it in Vertex Form. Technically, this is Vertex Form. But until you get used to seeing what this means, it's easier to look at here. And once you rewrite it like this, it's easier to tell what the vertex is, what the axis is going to create. So on your own, you can try moving. Write the vertex, write the axis of symmetry, tell me if it opens up or down. Tell me if it's been stretched or compressed, and then tell me if it's been reflected. Okay, so vertex. What is it? No, vertex. Good. Axis of symmetry. Good. Okay, up or down? Susie, up or down? It would be opening down. What makes it open down, Susie? Right. Or zero. The equation's right. I don't care. Okay? Because it's open down, what's the fancy word for saying it's open down? It's been reflected. So down and reflected will happen at the same time. If I ever say that it's opening down, I will also say that it's being reflected. Likewise, if it's reflected, that's what means it's opening down. Is there a stretch on this one? No. So that is my final answer. If you answer it out loud, you get 2 points. Everybody else gets 1 for the whole problem. Let's rewrite now part D in standard form. What would it be? Y equals what? 1/2 x plus 2 squared plus 0. Good. On your own, finish it off. Vertex, axis of symmetry, reflection, opening down, compression, stretch, everything. When you're done with that, I want you to find this place in your homework that I'm giving you right now that mirrors these kind of questions. Oh, I need to log in one thing. Oh, do I mind? Okay, so part D, what's the vertex? -2, axis of symmetry. X equals -2. Does it open up? Oh, look, this is open. Does it open up or down? Up. So, has it been compressed or stretched or neither? It's been compressed. Good. Now, somebody earlier asked, compressed, compression. This 1/2 and this 0.5 is the same thing, right? This one would also be compressed, right? Same number, just in a different form. Has it been reflected? No, because it's open up. This one, yes, there's been a reflection here. Okay. Have you found yet in your homework the types of problems that these refer to? Yeah. 10 through what? All right, well, if you're joining us, we, so weird talking to them. Okay, just ignore me. Forgot to push record, so just freeze frame and hopefully this makes sense. So you get the outcome. I don't even know if recording is anyway, but when I remember to upload them. Ooh, really quick, I don't know if this is your question. What does it mean to have the center or the vertex of the origin? What does that mean? 0, 0. Is that your question? Yeah, the vertex of the origin means that the vertex is happening at 0, 0. All right, finish up your problem, and we'll come back to the notes. Now the goal for the rest of the day is to just, well, mostly is just to graph it. So we're going to graph a few, and then we're going to flip the page and then give you the graph and you write the equation, and then we're done. And we'll hit all aspects of Vertex Form. So the first thing I want you to do, because it'll help it put everything in the right spot, is I want you to write the equation in Vertex Form, putting in the h and the k. So for part A, you've already done this one. It's y equals what? You can put the one if you want, x what? -0 squared plus 0, right? Now, I started to list the steps. The very first step is to plot the vertex, right? So the vertex here is at 0, 0. If I were to write the steps down, the second step is to use the pattern, the x squared pattern. So if you haven't, or if you forgot, this is the pattern. To get my next point, I'm going to go over 1 from the vertex and then up 1. The reason I do that is because 1 squared is 1. And then I go back to the vertex, and I go over 2, and up how many? 4. Good. Because 2 squared is 4. Now, in other classes, and it's too bad that our new students missing because I'm assuming they're taught it slightly different. In the other classes, they use a 1-3-5 pattern. I don't like the 1-3-5 pattern because, yeah, you can memorize 1-3-5. And how did they get 1-3-5? I can show you. But as you start talking about, like in secondary 3, we talk about x cubed, we talk about square roots, we talk about cube roots, and how you graph those. If you understand the 1-4-9, these are so much easier. So, anyway, that's why I did 1-4-9. Okay, so from the vertex, I go over 1, up 1 on both sides, right? Go back to the vertex, go over 2, up 4 on both sides. The rule is you keep plotting points until you run off the graph. If it's slightly off the graph, I like to put the 1 more on there just to make it pretty. I like the graph to cover the entire grid, or as much of the grid as you can. So I want the arrows coming up off the top, or going off down the bottom if possible. I don't know if it's like perfectionist issues or if it's, like when this is not the accurate graph, but if I see a graph that looks like this, it's not terrible. So, okay. What about this one, part B? How do I write that in vertex form? Y equals? So that means the vertex is where? Raise your hand if you know. Vertex at, Grace, do I call the name? Grace, you're up. 0, 4. Does that follow the regular pattern? Yes. So, over 1, up 1. Rest the vertex, over 2, up 4. So much better than doing the negative b over 2a, right? So much better than plotting the intercepts and then trying to like find a middle line and doing some weird thing. Makes me happy. Try part C on your own. It's just really hard to make a one-page graphing assignment because we've got to get so much writing. Where's the vertex on this one? Now, I probably won't rewrite part B. I'll probably just add a 0 at the end. There's no need to rewrite it. That's fine. Where's the vertex? 2, 0. Does it follow the standard pattern? Yes. So, and over 3 up. Fantastic. Any questions? Oh, 1, 2, 3, 4, 5. 5 things I totally did this. I was just about talking 5 minutes ago. And then 1 I don't want. Just don't do my thing. Okay, cool. Let's keep going. Part F. Rewrite it in vertex form. American?
So when it's bigger than 1, and then you do the thing where you go like 1 and then I can do that part if it were like 2 or something like that.
Let's practice that. Okay.
You only multiply the bottom one, or you multiply
You multiply it up. You multiply all of the ups. If we're doing over 1 up 1, you go over 1 up 2. That's because you're multiplying up by 2. And then up 8 because you're multiplying up by 1. Okay, so f, rewriting in vertex form would be y equals negative x minus 0 squared minus 1. The vertex is where? From here, 0. From here, negative 1. Okay. And does the pattern change? Yes, on this one it does change. Because a is negative, I'm going to take all of my ups and make them negative. You don't change the overs, you only change the ups. So, from here I go over 1, down 1. I'm moving. I would go over 2, down. Oops, this 4. And then if I could go over 3, down 9, I always would get this figure. So, something like that. Ish. That's really rough to catch for time. Okay, what happens then with part D? I added the 2, so we'll add this to the 2 as well. What happens with part D that we got that 2? You still find the vertex. Where's the vertex on this one? Negative 4, negative 1. And you look at the general pattern. Because A is 2, I have to change the pattern a little bit. What do? Multiply all of the ups by 2. So, instead of going over 1 up 1, I'm going to go over 1 up 2. And instead of going over 2 up 4, I'm going to go over 2 up 2. Good. So over 2 up. And it should look, because it's kind of a stretch, right? It should look a lot skinnier than the rest. It should look like the parabola is become one more times and then full tighter. So over 2 up 2. Notice how all of the parabolas, I mean, they look like the U. I agree it's still on sometimes, but kind of like, I mean, they look like they're coming in like that, really wrinkly, or like really wobbly. No, that is. So. Okay, last one. Let's extend the pattern a little bit, because we've only done the 2 and the 4. The pattern, over 1, up 1, over 2, up 4, over 3, up what? 9. And if I could go over 4, how far would I go up? 16. Good. The pattern is that because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Where's the vertex on part B? The opposite of this is exactly that. Now, this one has been compressed, right? How do I know it's been compressed? There was no 1/2. Good. Which means I'm going to take all of my ups and multiply it by 1/2. Which is the same thing as dividing by 2. This one should look a lot wider than the other. So for this one, I'm going to go over 1 up 1/2. I'm going to go over 2 up how many? 2. I'm going to go over 3 up 4.5. Good. 1, 2, 3, 1, 2, 3, 4 1/2, 8, 7, 9. And if I could go over 4, how high would I go up? 8. That's possible. So I do 1, 2, 3, 4 up. The more points you put on your graph, the more accurate your graph will be, the more likely you are to get full credit on the test. Okay, the last page of the notes will help with the first page of the homework, so sorry that those kind of went weird. The first page of the homework is where you take 9 graphs and you match them with the equations, but I have 12 equations listed. There are 2 typos, so I've got to fix those for you before you can do the first page of your homework. But just know that there are more choices than there are graphs. So they're not going to match one to one. Let's I think we're only gonna have to do like 2, maybe 3 of these. Now I'm gonna give you the graph and I want you to write the equation of the graph. So if I were doing page 1 on your homework, I would look at the graph, and then I would find the vertex, and then we look for the vertex, and then we find the equation. Kind of the same thing here. The very first part, again, the skeleton looks like this. X minus something squared plus or minus something. Where's the vertex in this case? Vertex is at positive 2, positive 1, right? So positive 2, positive 1. What's the stretch? To get the stretch, you go over 1, and then how high did you climb? So a equals 1. You don't have to put the 1. Y equals x plus 2 squared plus 1. So you can put the 1 if you want. That's it. Woo, done. Let's do it again. Number part B. Y equals something, x minus something squared plus something. What is the vertex? The vertex happens at negative 3, right? So this would be a minus 3, which would become a plus 3. So okay. And then negative 2. So instead of a plus right here, I'm going to need a what? A minus. Good. Negative 2. Questions with that? Then let's look at the stretch. From the vertex, I went over 1 and up how many? So this number right here is 2. Y equals 2 times x plus 3 squared. Let's do one more. Part D. The vertex is at 0, so y equals, it could be a stretch, at minus 2 squared plus 0. And what's the stretch, or the compression? I went over 1, up how many? It looks like a half, right? So if the pattern was 1/2, that means I would have multiplied this by 1/2, right? I'm just trying to check. This is the general pattern. If it was 1/2, I could go over 2 and up how many? 2. Did the graph go over 2 up 2? Yeah, so then that confirms for me that this stretch was 1/2. That was convenient. And you can either leave the 0 or take it off. All right, so you should know enough to... Thanks for watching. Peace out.